Saxon Geometry, Lesson 94. This is the law of sines. Now, before you get all excited about looking at this and saying, oh, more trigonometry, how can this be? This is actually going to save you a lot of time. And this is a part of trigonometry that is no longer based on it being only a right triangle. If we worked with sine, cosine, and tangent in the past in this class, they've always been based upon the premise that we were working with right triangles. Well, this one works with any triangle, and it has two equal signs in the formula. And we're going to discuss that and why that's important. It works out every time. You'll see where this is very useful. Okay, so I have a scalene triangle here. It's not a right triangle. And C is pretty close to being right, but it's not quite there, and we didn't label it that way. So we're going to say it's not a right triangle. And I want us to do some naming convention first of all. Remember that when you learned the Pythagorean theorem, it was just odd that we always use lowercase letters for that. There's a reason for that. That was because that was side lengths. And when we use side lengths, we use lowercase letters. It's just a convention. There's nothing that says it has to be that way, but it keeps it straight in our heads. The other thing that we learn to look at is that angles are capitals. Now, when we work with this, I labeled this on purpose. This was not accidental that I used ABC and ABC, because I want us to think about triangles with pairs. There are 6 pieces to a triangle, 3 angles and 3 sides. The angle is opposite to its side that corresponds to the same letter of the alphabet. In other words, this is the B angle. The B side corresponds to it. These are just adjacent sides. I don't know which is which. They're not unique. But a triangle only has 3 pieces to it, and therefore the only unique piece of that we could tie to this angle would be the opposite side, right? Because these could change in length. I can't just say the longest side goes with it. How would that work with the shorter angles and smaller angles and shorter sides? So I'm going to say this is B, this is B. If this is capital C, this is lowercase c. If this is cap A, this is lowercase a. Now, with that, we're going to write this formula. A over sine A equals B over sine B equals C over sine C. And I have seen some textbooks that have that completely inverted, and they say sine A over A equals sine B over B, which equals sine C over C. That's actually the same formula when you stop to think of it. That's like saying 2 is 2 or 1/2 is 1/2. Take the inverse of both sides, it means the same thing. And so these work with these double equal sign because they're telling you you can pick out any 4, not 6 parts of the triangle to solve everything else. So you only have to know 3, but you have to know a pair. So you have 3 known values, 1 unknown value, but you have to have a single pair to start with. Look at example 94.1. It says find xy, or xz, I'm sorry. So xz is this length here. So I'm going to work with a pair. Well, what is the pair to the 35? Well, that would be yz. What's the pair to the 20? Z. What is the pair to the 38? XZ. So 38 is my pair, but that doesn't really help me because I need to work with a pair so I don't have 2 variables in my solution. So when I look at this, I say 35 and 38. I bet you we could find this one, right? Well, a triangle has 180 degrees in it. All triangles do that we work with here. So 180 minus 35 minus 38 is 107. And therefore I can say Z has got to be 107. Now, I went ahead and labeled this. I redrew it on purpose, and I labeled it X and X, Y and Y, Z and Z, so that we could see we're working with pairs. Once I know this is 107 and this is 20, I can say 20 is to 107. That could be my A over A or my B over B. It doesn't matter. This is just to keep in our heads what the law of sines is, but when you remember that any pair equals any other pair, it doesn't matter. You no longer have to relabel everything or which one's A, I don't know, it doesn't matter. Okay, so I just look at this and say 20 is to the sine of 107, and I'm looking for the pair now of the Y side, right? Because that's the one I know, so Y is to sine of 38. That's the one I'm looking for. So this is with my variable, and this is my known value. So once I do this, I multiply both sides by sine 38. I get 20 sine 38 over the sine of 107. Now, this is where your calculator comes in handy. There are 2 different functions for sine on your calculator, the sine and the inverse sine. Now, on this one, we're going to be working with sine. If you need to grab your calculator, hit the mode button, make sure you're in degrees. It has to be in degrees because our problem has degrees in it. Once you've done that, hit sine of 38, hit equals, times 20, divided by, it'll open up a parentheses, sine 107, it'll close those parentheses, hit enter, and you'll get 12.88. And we feel real special about that because we just solved out an unknown side length. So this is 12.88, and this is 20, and this is very valuable because no longer do I have to have a right triangle, I only have to have a pair to find unknown pieces. Now, that's when you're finding an angle. This next example is when you're finding, a side. This is going to be when you're finding an angle. 94.2 says find angle L. So we've got angle L here, and I look at it and say, well, where are my pairs? Well, I've got a 14 and a 75 already ready to go for a pair. So I'm going to say 14 is to the sine of 75. There's my pair, and then I'm looking for L, right? Well, L has two variables in it. So instead of finding L, I'm going to find N. Because if I know two angles of a triangle, I know the third. So 12 and n are my other pair that I'm going to work with, so I only have one variable. And I'll say 12 over the sine of n, right? Because it's the sine of the angle. Now, this is where people get confused. I see it happen in year after year. I see students make the same mistake. They try to get rid of this 12 by dividing both sides by 12. Well, that would give you 1 over the sine of n. So what I'm going to do instead is I'm just going to cross multiply this and say 14 sine n equals 12 sine 75. Then divide both sides by the 14. That gives me sine n equals 12 sine 75 over 14. If you're doing it the other way and you say, I'm just going to get rid of that 12 by dividing by 12, you're going to end up with the reciprocal of the sine of n and not what you want. So when I get to this point here, this is where I'm going to use my calculator a little differently. Now, what I would suggest doing is finding out what 12 sine 75 is, divide it by 14, and then save that answer on your calculator. So it's on the screen, right? I'm going to hit the second key, sine, the second A and S. That's going to put that in there in my calculator for most brands at least. It's going to put that in as the angle whose sine is, right? We're not looking for the sine of this. We're looking for the angle whose sine is that. There's a difference. So when I'm looking for this angle, I'm looking for an angle, I have to hit second sine, and that's going to give me 56. Well, that tells me what n is. It's about 56. But that doesn't tell me what L is. The good thing is that I can subtract the 75 and the 56 from 180 and get my L, which is about 49 degrees. And these are very easy to work with. The law of sines does not need to be scary at all. It just needs to be thought through, keeping in mind a couple of the rules. One, I can use it this way, or I can use the reciprocal of it. I can't mix them. I can't say A over sine A equals sine B over B. I have to either put the signs on the top or signs on the bottom, but it has to be uniform. That's your first thing. The second thing that I have to remember is that I have to work in pairs. It doesn't matter how I label my angles as long as I realize that the opposites are pairs. So this angle goes with this side in the fraction, this angle goes with this side goes with this angle, and so on. And that's your second most important thing. The third is if you have a fraction in the denominator, cross multiply or invert both sides, or use a little bit more of that algebra 1 skill set that you already have, but you can't multiply by or divide by the numerator and expect to get rid of it. You'll end up with an inverse function of it instead of the original. So law of sines, very simple. Practice it. Go through with your calculator. Make sure that you know how to use the sine key and the inverse sine key for finding that. You use a sine when you're finding a side. You use the inverse sine when you're finding the angle who corresponds to that side.